Welcome to Mathematics with Tom. I am Tom, and today we are going to look at, this is 5.3 in our text, and we are going to use Cramer's rule, to find A inverse. And I'll put it as sub 3. In other words, A is a 3 by 3 invertible matrix to find A inverse. Well, how do we do that? And the answer is very carefully, and it'll take us a little bit of time. So here's how this works. Remember what Cramer's rule says. It says that, well, in order to find A inverse, we have to solve the problem A times some vector x gives me the first column of the identity, E1. And then we have to solve the problem of A times another vector y equals the second column of the identity, E2. And then we have to try one more time. Oops, not equals. Our third problem to solve is A times, we'll call it Z, has to give us the third column of the identity. So we have to, there's a bit to do here. Well, let's get started. To solve the first problem, what we have is we have some matrix A. It has columns of A1, and A2, and A3. And what we're going to do is we're going to multiply this by, now remember, right, Cramer's rule uses determinant. So the whole idea here is we have to write the vector x as a determinant. So what we do is we're going to start with the matrix x1. Well, x1 is going to be the matrix of x1, and then you're going to have e2, e3. And this is going to equal the matrix now, where normally it's b, but in this case it's e1. But then we're going to have a2 in the second column and a3 in the third column. And now you're going to need to make sure you're familiar with Cramer's rule. Here's the quick review. You can look at our previous videos. Well, what we said then is we said that if we take the determinant of the matrix A, that's equal times the first component of x, which is x1. This will equal the determinant of this other matrix we called this. This is their matrix B1. So equals B1. Okay, so here's what we need to do then. Or you could say that x1 is equal to the determinant of B1 divided by the determinant of A. So here's what we need to do. We need to find the determinant of B1. And I think that the result will be a bit surprising. So the determinant of that. So the determinant of x1 is, well, e1 is 1, 0, 0. Then a2 is going to be a21, a22, a23. And it's going to have an a31, a32, a33. Now, here's something interesting. Watch this. So when I take this determinant, I'm going to have a 1 times my first cofactor matrix, the first cofactor, C1, 1. And then I'm going to have a minus A2 times the second cofactor, C1, A1, 2, C1, 2. Then I'm going to have a plus A1, 3 times C1, 3. Now, what I want to do, that's a lot. This does not look like a solution that's of any interest. This looks more bothersome. However, it's when you look closer that you'll see what happens. Look at this. For the cofactor matrix, the submatrix that goes with the cofactor C1, 2, says you would cross out the first row and the second column. Well, if you do that, notice this. You have a column of zeros. That means the determinant, it's the determinant of a dependent matrix. So this term here is 0. And for C13, clearly you need a yellow for that. That says cross out the first row and the third column. Well, if you do that, you're going to be taking this subdeterminant. But again, it's a dependent matrix, and so this component goes to 0. So the answer is that the determinant of x. Oh, not I said x1. You should have said something. It's not x1. It's b1. Determinant of b1. The determinant of b1 then is c11. All right, there we go. Let's try this again then. That's kind of interesting. So then what about when we go to solve our next solution then is going to be when we solve a, the determinant of a for x2. Well, then we're going to be solving b2. Well, for the determinant of b2, that's going to be the determinant of, now I'm going to have a11. That's the first column of a21, a31. And now we've put E1 into the second column. So that's going to be 1, 0, 0. And then we're going to have our third column of A31, A32, A33. Well, now let's grab a color. Like for example, or let's expand this. The first thing this says, now you're going to have an A11 times C11. Then you're going to have a minus A12, which is 1. So minus 1 times C12. Plus you're going to have an A13 times C, what's that, C31. Oh, you know what? I'm going to just leave this as a plus because that sign should be in the cofactor component. So we'll just make sure we'll keep the signs in the cofactors. But now let's take a look at this. The A11 says you would cross out row 1, column 1. That's going to give me a 0. C12, well, C12, that's going to be this yellowish green one, says I'd cross out row 1 again, but now I'd cross out row 2. Well, that's actually going to be a legitimate determinant. And then my final one comes from C31 that says cross out row 1, column 3, but that's going to also be dependent matrix, and so submatrix M. So that's also 0. So in other words, what we found is that x2 is equal to C12 divided by the determinant of A. And let's try this one more time. Actually, we'll do it a couple more, I think, to develop it in its entirety. So the final one would be the determinant of A. And we know that's going to end up with the determinant of the matrix x3. That's going to give us the third component of x. That's going to be equal to the determinant of B3, where B3 will have the first column of A, which is A11, A21, A31. And then it's going to have the second column of A, A12, A22, A32 times, and then we're going to have E1 in the third column. 1, 0, 0. And you can look at this already and see that if you have, you know what, let's write it out. So this is A11, C11 plus A12, C12 plus 1 times, this is going to be 1 times C13. Well, look at this. These first two cofactor matrices are going to include the 0 zeros in them. So both of those equal 0. And we're left with that x3 is C13. 3 divided by the determinant of A. Now, I would leave finishing this exercise to you, but I wanted to just walk down this path for finding this solution here for solving the second component of the inverse matrix. So I'm going to go to a new screen, and we're going to put that together. So what this is now we're going to solve A times the vector y is going to give me the second column of A inverse. Well, so we're going to first have A times the matrix of y1 is going to equal, gosh, I called it B. We should call it like I don't know, maybe the D. We'll call it D. So now we're going to be solving for D1. Well, we know that we're going to now we have square matrices. We'll take the determinants of those, and so now we'll have the determinant of A times the first component of the vector y equals the determinant of the matrix D1. Well, D1 now has this E2, which is 0, 1, 0 in the first column. And then what does it have? Then it has the second column of A, 1, 2, A, 1, 2, sorry, A, 2, 3. And the third column of A is in the third column of D1. So A, 1, 3, A, 2, 3, A, 3, 3. Okay. And now when we take the determinant of this, doesn't really matter how we do this. So we could have 0 times C, what would that be? C1, 1, but that doesn't do us any good now, does it? And then we could have plus, we could have a 1 time, oops, not 1. Yeah, you know what, let's just go down. We're going to go down. So now we're going to take the 1, and then that's going to be the cofactor matrix for row 2, column 1, plus then we're going to have the 0 times the cofactor C, let's take 3, row 3, column 1. So, but look at those. Notice that I have, these first two have 0 times them. So the only one of these that we pick up is the cofactor matrix of C21. Now, you could have done that going across as well, but now this is much easier. So we'll do it that way. Now, let's see what happens for y2. So now we've solved it. Oops, y1 equals C21 divided by the determinant of A. Now, then y2, well, y2 is going to be 1 over the determinant of A times, now the matrix of D2. Well, the matrix of D2 is going to have the first column of A, A11, A12, A13. Then E2 will now be in the second column, so 0, 1, 0. And then we're going to have A13, A23, A33. Whoa, hold on a second. So now, you know what? I like this idea. Let's use our scalars from the third column. So now we would have a 0 times the 0, the submatrix or the cofactor of 0 then is the C2 row 1 column 2 plus we have 1 times, this would be the cofactor for 2 plus 0 times the cofactor for 3, for row 3 column 2. And that is just C2, 2. And our final one for y, and then I'll leave z for u, is 1 over A, the determinant of A, times, this is going to be A11, A12, A13, A12, A22. Oops, I made a mistake in the first column, didn't I? This should have been A2, 1, and A3, 1, and then A3, 2. There we go. And now E2 is in the third column, 0, 1, 0. Well, let's just use that third column for our coefficients on the cofactor formula. So I'm going to have 0 times the C13 cofactor plus 1 times the C23 cofactor plus, plus I'm going to have 0 times the, oops, hang on. Yeah, row 2, column 3. Okay, plus, sorry, 0. This is a lot of indices to keep track of. C, that would be the 3, oops. I gotta think about that. 1, 3, 2, 3, 3, 3, C3, 3. But that's just going to be C2, 3. So let's look at what we have. So far is we have, let's just write this. Let's write the matrix of C. Well, the matrix, the cofactor matrix, would clearly be C11 and have C12. Oh, oops, nope. C21, C31. And then you have the C12, C1. Gee whiz, 2, C22, C3, 2. And then our third column would be C3, 1, C1, 3, C2, 3, C3, 3. Okay, but now let's look at our A inverse. Our A inverse is equal to 1 over the determinant of A, because that's in every term. So let's just factor that out. Times, well, we said that x1 was from the previous page. Let me go back and bring up my, oops. Let's go back and bring up x1. And x1 was C, oh boy, where are we? Oh, C11. X2 is going to give me the C12. X3 is C13. All right, so let's write those. So I'm going to go back to my other page. So x1 would go in this first column, and we said that's going to be, this is going to be C11, C12, C13. And now if we look at our y's, our y1 was C21, then a C22, and then a C23. And I'm going to tell you what happens. Then the z's are going to give me, z1 is going to be Z31, C32, C33. Well, hold on a minute. If you're thinking my indices were all off, it's not. What it is A inverse is 1 over the determinant of A. It's 1 over the determinant of A times C transposed. Wow, that's what we just found. That's what we've just found. Now, we're going to do one more thing. One more thing to do with this, and then we'll call it a good little lesson for the day. And that is there should be a bit of concern. Let me show you what I mean first. What I want to do is show that A inverse, in fact, equals I. Well, notice this, that now we said that this is A times, well, A inverse we said is 1 over the determinant of A, 1 over the determinant of A, times the matrix of C transposed. And we want to show this is true. Show true. Okay. So here's how we're going to do this. I'm going to just clean this up a little bit because the 1 over the determinant of A is just kind of a nuisance to write. So let's just work with A C transpose is equal to the determinant of A times the matrix of I. Here we go. So A is A11, A12, A13 times, second row is A21, A22, A23, A31, A32, and A33. And yeah, you really do need to write these out to see how this works. And we said that the cofactor C transpose means all of our indices are backwards now. So this is really C11, C12, C13. And then we have C, this is going to be 21, C22, C32. Finally, C31, C32, C33. Wow, this is really a lot to undertake, but we're going to do this. So let's start with the obvious. Let's just start with row 1 transpose times column 1. We'll just call it capital C1 for the first column of the matrix C. Well, that's going to be A11, C11 plus A12, C12 plus A13, C13. Well, wait a minute. That we know for sure. We derived, that's the most cleanest way to look at. That's the cofactor matrix, cofactor formula. That is the determinant of A. So now we've got the very first entry. Okay. And let's try this again. Let's try the diagonal. Let's try row 2 transpose times the second column, C2. That's going to be A21 times C21 plus A22, C22 plus A23, C23. Well, notice this. All the indices match. In other words, what was really happening, that there's 2, 1, 2, 1, 2, 2, 2, 2, 2, 3, 2, 3. So when we normally just work with the first row of the cofactor when we take the determinant, but you can work with any row and just cancel the rows and columns according to the cofactor formula. So this is also just another way of going after the determinant of A. And so there is our second element of the diagonal. And it works one more time for the third element of the diagonal. The question, though, are the zeros. How do those zeros come about? Or did we make some egregious error and it's all wrong? Let's find out. Let's just pick one. Let's pick, for example, let's take row 1 transpose column 2. So this says that I have A11 times C21 plus A12, C22 plus I have A13, C23. Now that to me is just not obvious. Not so obvious. Oh, wait a minute. Let's try this. This is A11. Remember what C21 is? Well, let's write it this way. This is some kind of a determinant. The question is, it's the determinant of what? Well, let's just see. We have A11, so we're using A11. We have A, and then it says the submatrix of C21. Now, C21 means you would cover row 2, column 1 of A. So I'm going to do that. Row 2, column 1, row 2, that's right there, column 1. Okay, so that's going to pick up the submatrix of A 1, 2, A 1, 3, A 3, 2, A 3, 3. And now let's do this again. Now I have here's A 1, 2, and it is the submatrix of C2, 2. C2, 2 would mean row 2, column 2. So I would cover up the row 2, which already is, but this time I'd cover it in blue, column 2. So that would leave me now with A1, row 2, yeah. So that would leave me with, did I make a mistake on this first one? I think I did. Hold on a second. Oh, I totally did. A 1, 2, A 1, 3. There we go. And then, okay, there it is. Now the next one says A 1, 2, and then I would be left with C2, 2. So C2, 2 would leave me with A 1, 1. We've got that. It would leave me with A 3, 1. Like that. And and the other piece of this is that row 2 is just A 2, 1, A 2, 2, A 2, 3. Oh, just a second, I did something totally wrong. I hope you never have one of those moments. I just did. I have a lot of subscripts going on. Let's go back and let's make some corrections. Here we go. So I said, let's do this. So A11 times the submatrix is C21. Well, the C21, let me go back and let's do this in orange. The C21 submatrix means you'd cover up row 2 and column 1, and that would give me the subdeterminant of A1, 2, A1, 3, A3, 2, A3, 3. And then look at what happens. Now I multiply by A1, 2, and it say multiply that by the cofactor matrix of 2, 2. Well, that is A1, 1, A1, 3, we have that. And then it's going to be A3, 1, A3, 3, and we have that. And finally, our last one is A1, 3 times the 2, 3 cofactor matrix, the 2, 3 cofactor matrix, which would be row 2, column 3 would be covered up. So that would mean we're looking at taking the cofactor matrix would be A1, 1, A1, 2, and then with the determinant, and then A3, 1, A3, 2. That is right there. But wait a minute, look at what happens when you put all this back together. I'll show you. What happens is this equals 0 because we have dependent rows. Dependent rows. Notice in this case that row 1 is equal to row 2. And that's what happens then on any single one of these. If the indices, if indices don't match, if indices do not match, then 0. And there's our 0, 0, 0, 0, 0, 0. And as we thought, A times the cofactor matrix transpose does in fact equal the determinant of A times the identity. I hope that helps. Thanks for watching.